Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will use log laws to simplify logarithmic expressions. So the three log laws you need to know are on your screen in blue. So let's first discuss how they come about. Well, remember, logs are the inverse or opposite of raising to a power. Raising to a power and taking the log, they undo each other just like multiplication and division undo each other. So these first two log laws are just like the opposite of index laws we already know. So we know from year 9, if you multiply together bases, you add together their indices. We know that if you divide the same base, you subtract their indices. So the opposite's true for log. Here, when you multiply, you added the powers. For logs, when you add the logs, you multiply the powers. You keep the same base, and you multiply these two numbers together. Similarly, when you're subtracting logs, you divide the powers. You can combine these two into one log, keep the same base, and divide these two numbers. So the third law is when you have a second power. So here we have log base, power, and a second power. We can move this second power to the front, which is what I've done here. All right, let's use these three log laws to simplify these expressions. So let's look at this first one here. So we've got two logs of the same base, base 2. So all we do to combine them into one log is we keep the same base and we multiply the powers. 5 times 7, 35, and we're done. So let's look at this one here. Now I'm subtracting logs. Now, if you forgot, ln means natural logarithm or log base e. So I've got two logs of the same base that are being subtracted. So what I do is I keep the same base and I divide their powers. X squared divided by x. So x squared divided by x is just x. So it turns out we could also have used this law to help simplify this. So this has two powers. This is log base e, power x, a second power 2. So we could actually have written log of x squared as 2 ln x. We're just moving the second power to the front. And then I have 2 log x minus log x. And of course, 2 of something minus 1 of something gives you 1 of something. 2 log x minus log x just gives me here, log x. Log base e of x. So note, we couldn't use this rule here on this expression because of the 2 out the front. So let's try this expression here. It's not at all obvious which of the log laws I could use, but what I can do is I can simplify this. I can actually evaluate it as a fraction without using my calculator. So how am I going to do this? Well, what I want to do is I want to write these two as powers of the same number. So this requires a knowledge of powers. You just have to know that 32 is 2 to the power of 5 and 16 is 2 to the power of 4. So how can I simplify this? Well, what I can do is use this law here because I have two powers. This is log base e, power of 2, and a second power of 5. So I can simplify this as 5 log base e of 2 over 4 log base e, natural log of 2. So natural log of 2 is just a number. It's about 0.69, so I can divide from the top and the bottom, and I'm left with 5 over 4. And how cool is that? I had an irrational number here, natural log of 32, some irrational number that none of us would know off the top of our head. Similarly, natural log of 16, irrational number we wouldn't know, but we've made this into a rational number without a calculator using this log law here. So note that the answer here was 5 over 4. You can't just cross out the logs and get 32 over 16 is 2. You can't cross out just log by itself because it's not a number. You can, however, cross out natural log of 2 on top and bottom because they are just numbers. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.